Hello all, welcome to KT Semicon self-based learning module, and in this particular session we are going to start with APB interface signals. In our previous session we have discussed about the introduction to APB interface and what do you mean by APB and where we can use our APB interface. Now in this particular session we are going to see what is this APB interface signals, what are the signals which are associated with our APB interface, right? So let us move forward with it. Let me share my screen. Let's say if I'm going to have a simple master with me and a slave connected like this, okay. Now with my master, I'm going to have few signals associated with it. Now, if you carefully observe, the signals are denoted with the name P, okay. So every signal is going to have a letter P with it. So we are going to have the very first signal is P clock. So P clock is a signal which is a clock signal which we are going to have. So using this particular clock signal, we are all the transactions or all the master and slave is going to communicate with it, right? So using this P clock, this is the main clock for the APB system, and all the transfers are synchronous to the rising edge of the clock. Okay, because this APB protocol is a synchronous protocol, so all the transfers are synchronous to this particular clock. Next is we are going to have something known as P address. Okay, so the next signal which we are going to have is P address, and this is output to our master. Now, what do you mean by an address? Basically, for this address, we are going to have two functionalities. The very first functionality of this address signal is to select your slave. So, if the master wants to communicate with a particular slave, it is going to use this address signal and it is going to establish a connection with that particular slave. So for that particular thing, we need the address. And second thing is in this APB protocol, if we want to send any particular data, we cannot send it as it is. We need to bind that particular data with some particular address. For example, if we are going to send a data, let's say if we are going to send a 32-bit data FF, which is a 32-bit data which we are going to send, and sorry, this is a 8-bit data. Let's say if we are going to send a 32-bit data like this, let's say we cannot send it directly using the bus. What we need to do is we need to tie up a address with that particular data. So this protocol mandates the tying, right? So if you want to send any data or if you want to receive any data, you need to definitely associate a particular address with that particular data. Then only you can send or receive that particular data, right? So that is nothing but my P address, okay, which is basically of 32 bits width. Next is PROD signal, which is an optional signal that we are not going to consider about, which is an optional signal. This is basically protection signal. It is categorized into normal, secure, and instruction, which we are not going to discuss in our course. Now we are going to have one more signal as P select. Okay, so this signal is used to select a particular slave, and it is also a output to our master. Using this P select signal, you are going to basically select a particular slave. Let's say if we are going to have three slaves like this, and we will have a decoder over here. So let's say if the P select of this particular slave has been selected, then this slave will be established the connection between our master and slave. The master will be established. The master will start communicating with this particular slave if this P select has been activated. Let's say if this slave has been activated, then the master will communicate with this particular slave. And let's say if this slave has been selected, the master will establish a communication with this third slave. So depending upon the P select signal, the master is going to establish the connection between that particular slave. So using this P select signal, we are going to establish that particular connection. Next is P enable signal. So this P enable signal is used to differentiate between the address phase and the data phase. So in AHB protocol, we have already discussed about this particular terms like address phase and data phase. Here also we will discuss what do you mean by an address phase and what do you mean by data phase. So this P enable signal is going to decide whether we are in address phase or whether we are in data phase. So if this P enable is equal to high, then it is an address phase, and if this P enable is equal to low, it is an address phase, and if this P enable is equal to high, then it is a data phase. Okay. Next is PWRITE signal, and this P enable signal is also output to our master and input to our slave. Now, next is we are going to have one more signal which is known as PWRITE. So, what do you mean by PWRITE signal? So, this PWRITE signal is used to decide whether to perform a write operation or whether to perform a read operation. Now, if PWRITE is equal to 1, then it is a write operation, and if PWRITE is equal to 0, then it is a read operation. Okay. So, what do you mean by write operation? If the data direction is from master to slave, it is a write operation. And if the data operation is, if PWRITE is equal to 0, then it is a read operation and the data direction is from slave to master. So in the case of your write operation, you are going to write the data from master to slave. And in the case of read operation, you are basically going to read the data from the slave. Okay. So depending upon your PWRITE, if it is equal to 1, then you are going to write the data into the slave. And if it is a read operation, PWRITE is equal to 0, then you are going to read the data from the slave. Okay. And it is 1 bit. So your P enable signal and P write signal, these are basically of 1 bit width. Okay. Next is something known as PW data. Now, what do you mean by PW data? Let's say if you have made your P write signal to 1, okay, that means it is a write operation. Let's say if you have made your P write is equal to 0, then it is a read operation that we have seen just now, right? Let's say if your P write is equal to 1 and if you want to perform a write operation. Now, how we are going to send the data? Using this PW data bus, you are going to send the data. For example, this is our master and this is our slave. Right. Now, let's say if you want to send any data to the slave, how you are going to send the data to the slave? You need to have some bus, right? So we are going to use this particular signal, or you can say as a bus, which is known as PW data. Okay, which will be of generally 32-bit. Okay. So using this PW data bus in the case of your only write operation, I'm stressing on this particular point, only in the case of write operation, using this PW data bus, I'm going to write my data or I'm going to send my data to the slave. Okay. Next comes this P strobe signal. This we are not going to discuss because it is an optional signal. Okay. Next, next comes the set of signals which is known as PREADY. So which is of also 1 bit width. Now, what do we mean by PREADY signal? Let's say if the master wants to communicate with the slave, but the slave is not ready for the transfer or the slave is not ready for that particular type of communication. So what is the slave is going to do? It is going to assert this P assert to 0. If this P ready, sorry, it is going to assert this P ready to 0. If this P ready is equal to 0, that means the slave is not ready for the transfer, which was initiated by the master, right? So the master first it will sample our P ready signal. If it is equal to 1, then only the master is going to initiate the transaction or initiate the communication. But if our P ready it is equal to 0, then the master is not going to initiate any transaction. Okay. So depending upon your P ready signal, the master will decide whether to initiate any transaction or whether not to initiate any particular transaction. Okay. So that will be decided by our P ready signal. Next. So let's say if our master wants to read any data, so this is our master and this is our slave, and slave is going to read the data from our master. Sorry, master is going to read the data from the slave. Okay, it wants to perform a read operation, right? Now, so how it is going to read the data from the slave? So using this particular signal which is known as PR data signal. So using the signal which is known as PR data signal, the master it is going to read the data from the slip. So during the write operation, the master has used PW data, right? So if it wants to read the data, it is going to use PR data. So using this PR data signal, the master is going to read the data from the slip. Okay. So if we want to perform the read operation, then we need to make our P write to 0. And if our master wants to read the data from the slave, then it is going to use this PR data signal for reading the data. So this was about our signals which are associated with our master and slave in the case of our APB signals. We don't have burst and trans. Okay, so these signals are not present in our APB signal, and those are present in our AHP interface. So that's all about this particular session. Thank you.